All right, let's jump right in. We all know about legacy code, right? For decades, it's been this silent anchor holding back so many businesses. It's that ancient, undocumented system that absolutely no one wants to touch, but hey, everyone relies on it. And it's not just a tech problem, it's a huge business obstacle. But what if we're standing on the edge of a revolution? A time when AI doesn't just write new code, but it finally helps us understand the old stuff.
So let's start with a number that should honestly make any engineering leader pause. Industry reports are showing that a staggering 40% of all engineering time, it isn't spent building what's next. Nope. It's spent wrestling with the past. Just think about that for a second. That means for every 5-day week, 2 of those days are just gone. Poof, lost to untangling tech debt and just trying to figure out what some long-forgotten code actually does.
And this quote, this just nails it. This is the heart of the problem. Modernization projects don't fail because your team lacks skill. They fail because they lack knowledge. The issue isn't that your engineers can't build a slick modern replacement. It's that they first have to become digital archaeologists, carefully digging up the business logic that's been buried for 30 years. And that discovery process, that's the quicksand where projects go to die.
So, how in the world do we fix this discovery problem? Well, we're seeing this massive shift in the tools we use. We're moving away from simple code checkers and into a whole new era of genuine code comprehension. And it's all being powered by AI.
Now, what's so cool here is how the whole perspective changes. See, traditional tools, they're kind of like a grammar checker for your code. They look for specific, known mistakes, one file at a time. It's like trying to understand a novel by just reading one random page completely out of context. But these new AI solutions, they're totally different. They read the entire library. They can see how Chapter 1 connects to Chapter 12, and from that, they figure out the plot, the actual business logic that stretches across the whole system.
I know, that sounds a little bit like magic. But how does an AI actually see an entire code base and make any sense of it? Let's pop the hood and take a peek inside that black box to see what's really going on under there.
Okay, so the first secret ingredient is something called the context window. The easiest way to think about it is as the AI's short-term memory. See, older tools could only remember the one file they were looking at right then. But modern AIs, they have a massive context window. We're talking the equivalent of holding an entire encyclopedia set in your head at once. And that is the key that lets an AI trace a single click from the user interface, follow it through multiple different services, all the way to the database, and actually understand the entire journey.
So the AI has this super wide view, but what is it actually looking at? Well, it's not just reading text like you and I would. The very first thing it does is build something called an abstract syntax tree, or an AST. So instead of a flat wall of characters, the AI creates this structural blueprint of the code. A great analogy is to think of it like the code's DNA. It reveals the precise, unchangeable relationships between every single function and variable. It's the foundational map for all real understanding.
And that blueprint is just step 1. The AI actually builds its understanding in layers through this multi-pass process. So, first it builds that structural AST we just talked about. Then, it goes back through and explains what each little component does. After that, it maps out all the connections and dependencies across the whole system. And only then, with all of that context locked in, can it put it all together to figure out a high-level business rule like calculate expedited shipping fees for premium members on international orders.
Okay, this deep technical stuff is fascinating for sure, but the real story, the reason we're talking about this, is what it actually enables. So let's pivot from the how to the so what, and look at the absolutely dramatic, quantifiable return on investment here. Let's look at a real-world case study from ThoughtWorks. Manually trying to reverse engineer a single complex COBOL module, to understand it well enough to rewrite it, took them about 6 weeks. With their AI-assisted tool, they slashed that time down to just 2 weeks.
So the key point here is, this is a 66% reduction in effort. That's 2/3 of the time spent on the single biggest bottleneck in pretty much any modernization project. Just gone. We're talking 4 weeks of your most senior engineer's time saved on every single module.
Now, what happens when you scale that up? I mean, really scale it up. On a huge mainframe project with, say, 1,500 modules, that time savings adds up to 240 full-time employee years. What does that even mean? It means a team of 24 developers can now do in 1 year what would have previously taken them an entire decade. That can literally be the difference between a project getting funded or getting canceled. And the speed boost isn't just for the initial analysis phase. Other studies are showing that for the actual hands-on work, the rewriting and refactoring,
These tools give you a 5 to 10x acceleration. The entire modernization lifecycle, from beginning to end, just gets put on hyperdrive.
Now, I know what you're thinking. This all sounds like a silver bullet, right? The magic answer to a problem that's been around for decades. But look, with any powerful new tech, the hype can hide the hazards. To use these tools right, we have to be brutally honest about where they fall short.
The risks really fall into two main buckets. First, you've got the risks from the AI itself, things like hallucinations, where the model gives you a really confident, plausible-sounding explanation that is just completely wrong. And then you have some really critical operational risks, like data privacy if you're sending your company's secret sauce to a third-party service, or just the simple fact that a lot of this tooling is still pretty new and can be a bit flaky.
And this quote right here, this is the golden rule. You have to treat the AI's output as a first draft, not the final copy. It's a hypothesis that needs to be tested. It gives your expert a massive head start, saving them weeks of boring work, but their most important job is to then challenge, verify, and polish that draft into a ground truth you can actually build on.
Which brings us to what might be the most important point of all. This is not about replacing human experts. Not at all. It's about transforming their jobs. The AI becomes this incredible force multiplier, changing the role of a senior engineer from a digital archaeologist to an expert validator. It amplifies their expertise. It doesn't try to substitute for it.
So, what does this all mean for your next big modernization project? Well, it means the old playbook, the one with those endless manual discovery phases, it's now officially obsolete.
The day-to-day work just changes completely. An expert engineer no longer has to spend a month in a dark room tracing some obscure function call. Instead, the AI generates a functional spec in a couple of days. The engineer's role then shifts from being a detective doing painstaking work to the much faster, higher-value task of validating what the AI produced. It's a fundamental move from manual labor to strategic oversight.
And this new playbook, it unlocks things that were pure science fiction just a few years ago. Take this idea of binary archaeology. This is for the ultimate nightmare scenario, right? Where the original source code is just gone. It's like finding some ancient machine with no blueprints. This technique basically points the AI at the machine itself, the compiled program, and has it reverse engineer the original plans from scratch. Incredible.
And that brings us to one last big question. For decades, modernization projects have been absolutely haunted by this goal of feature parity, that incredibly expensive need to recreate every single little quirk of the old system. But if an AI can quickly and accurately tell us what the system actually does, and more importantly, which features are truly critical for the business, how does that change the very definition of a successful rewrite? What new possibilities open up when we're finally free from chasing ghosts in the machine?